feel like you're right back at work. But I think this is a pain point for a lot of organizations. So at least I'm hoping that it'll be useful. So my name is Siva. I'm a security engineer at DoorDash. And today I want to talk to you about software composition analysis. Yeah, so just a quick intro. Software composition analysis is a way of finding software vulnerabilities in your dependencies. Well, vulnerabilities and licensing issues, but I'm sure everyone in this room is more interested in the vulnerabilities aspect of this. Uh, when we're talking about software composition analysis, a lot of people focus in on the scanning, but if we want to get it right, as the title kind of implies, we also need to talk a little bit about triaging and remediation. So my goal today is to kind of talk about the things that we are doing at DoorDash, the things that we were doing at DoorDash, and kind of where we want to be in the future, things that work for us and things that didn't work for us, so you guys can kind of like learn from our experience. Yeah, so before we get into any of that, we need to understand how outdated components actually enter your supply chain. So we like to think of this in two main ways. One is like, developers will introduce an outdated component through a PR, for example, and the way you kind of deal with this is you have to find a way to close those floodgates, right? And the second one is, developer adds a dependency and completely forgets about it, and they start getting security issues in them. And the way we want to think about this is, to enforce proper dependency hygiene and to kind of incentivize developers to go and deal with those outdated dependencies. Something else that people might want to consider is at the scale at which some companies like DoorDash operate. For example, these are the latest stats that I was able to pull. We have 3,000 plus developers working on over 600 microservices. We have a microservice architecture. We have some monrepos that are getting over 95 daily commits. Okay, so now with that context, let's kind of take a look at some scanning approaches that we can consider. Okay, so there's three main scanning approaches that we can take. So the first one is a periodic scan. It's a scan, as the name implies, that will run at a set cadence. I actually picked this up from a pet store on the way to the airport. So this is how we kind of like implemented this at DoorDash. So we have a Jenkins cron job that runs, reaches out to an internal service called asset service. We get, which contains a catalog of all of our assets. We clone those service repos, run our vendor CLI tool, and upload the findings to our vendors. So this has some advantages in that it's easy to implement with almost little to no involvement from engineering. But one of the disadvantages that we found is that, so turns out a lot of these CLI tools, the way they work is under the hood, they're actually using the package manager to build a dependency tree and parse it. So in many cases, when we want to run these CLI tools, we also need access to the build environments. And our team was actually having a lot of trouble maintaining build environments for all these different services that we were scanning. And the other disadvantage is that developers have to wait a day to see the results. So whether they're like remediating an issue or they are introducing a new vulnerability, we have no way of stopping these issues from entering our code base. So they have to wait a day to see these results. The second approach that we kind of considered is an SEM integration. So in this case, the vendor will integrate with your SEM, GitHub in our case, listen to some commit events, and asynchronously scan the code on their end. And if they detect any vulnerabilities that violate our security policy, they can set a GitHub status on the PR and try and block the PR, right? Again, this has some advantages. It's in that it's easy to implement, And now we have PR scans, so we have a way to close those floodgates to kind of, prevent new issues from entering our code base. But one of the big disadvantages is that it's really hard to determine what transitive dependencies are based by just statically analyzing your dependency file, right? Unless, of course, you have a log file, it's very hard to do this. And a lot of our service reports did not have log files, so we were having issues determining our transitive dependencies. Also, we had a lot of monorepos, and it was actually kind of hard to implement this for monorepos. For example, we wanted the information, this dependency graphs per service, basically, and it was very hard for us to get that information with existing SCM integrations. The last approach that you could use is like you could try and run your scans in CI/CD. So CI/CD stands for continuous integration and continuous deployment. It's essentially like an automated way of building, testing, and deploying your code. Turns out you can also run your scans in these pipelines, right? The way we implemented this at DoorDash is that we had a custom Jenkins step, and for main branch commits, we would use our vendor CLI tool, and we would scan the code base and upload a snapshot. And for feature branch commits, we would actually download the snapshot, diff it against the local snapshot. If we find any new vulnerabilities that violate our security policy, we'll actually set a GitHub status to block the PR. Okay, so this had some obviously advantages as in that we can implement PR scans, but it's also high accuracy. We have good transitive dependency information because we're actually performing the scans in the build environment. But sooner or later, we actually ran into some roadblocks, mainly in that this implementation is very build system dependent, and it's and any issues with CI/CD, your scanning can actually break the CI/CD pipeline, which can kind of upset engineering and slow them down. Just to give you some examples, we ran into those exact same two issues at DoorDash. The first one is our vendor took a really long time to support Kotlin 8. We're actually a Kotlin shop, so we use Kotlin for backend development. So they took almost a year to support Kotlin 8, so it ended up breaking a lot of our existing scans. And secondly, our build teams decided to make a big change to the infra and deprecate Jenkins and move to build kites. So everything that we've currently worked on kind of got got obsoleted, basically. So we're back at the drawing board now. We have to find a way to do this without running into the same issues again. And we started looking into SBOMs, right? So SBOMs are like a standardized document to which show like your software components of your application, basically. So SBOMs can, by the way, I pulled this from the CycloneDX specs. Shout out OWASP, they're here. Yeah, SBOMs can actually contain a lot of information, but in our case, we're just interested in the dependencies, right? So this is kind of what we proposed to engineering, right? We said, well, regardless of what build infrastructure you end up using, you need to generate an SBOM for us for every service and upload it to a shared S3 bucket, right? At the same time, you need to trigger one of our Argo workflows. By the way, Argo workflows is an engine for orchestrating jobs on Kubernetes, so it helps us with that scaling issue that we talked about earlier. So what our Argo workflow does is it pulls down those SBOMs, and it essentially scans them. By the way, if you are interested in using this approach and you decide to generate SBOMs, like CycloneDX SBOMs, there's a cool tool called Dependency Track. It's open source, and it's free, which is, this is not exactly how we do it at DoorDash, but I figured I'll give a shout out to the open source tool here. We have tested it, and it works really well. So you can use something like dependency track to actually scan your SBOMs. Feature branch commits are actually also pretty easy to implement with SBOMs because what engineering does is they upload an SBOM for the commit. We diff that SBOM against the main branch SBOM. We see what new components are added, and then we reach out to our vendor to see if that new component contains any vulnerabilities. If it does, we set a GitHub status on the PR to try and block it. Okay. Well, now that we have triaging, now that we have scanning in place, you're obviously going to be overwhelmed with findings. I know everyone who does this is. Less than 2% of your findings are actually true positive, if that, right? So I'm going to suggest some things that we do at DoorDash that help us, kind of navigate this, right? The first one is like we set benchmarks. So we choose the vulnerability classes. So we choose deprioritize certain vulnerability classes like denial of service and prioritize certain services like edge services, right? The second thing that you can kind of look into is reachability analysis, right? So reachability analysis is not always possible, but depending on your architecture, you may be able to do it. So it's to use your static analysis tools to, like SemGraph, for example, to see if the SCA findings that you found are actually reachable in your code base. So this will help reduce your false positive rate massively. And thirdly, we upload the findings to a vulnerability management platform. At DoorDash, we use Defect Dojo. So this kind of helps us deduplicate findings across services or even like within services. Oh no. So okay, this is kind of like an overview of what we're doing, and as you can see, like we scan the SBOMs and upload the findings to Defect Dojo, and our security engineer is triaging things from this vulnerability management platform. Okay, so now that you've identified the issues, you probably send it to engineering to remediate, right? This has it's very easy to overwhelm engineering with these findings. So we have two things that we do at DoorDash that that I kind of want to talk about. The first thing is setting reasonable vulnerability SLAs. It's not easy to fix things overnight. I think we had other talks about like empathizing with engineering. So I suggest that you work with engineering to actually remediate issues and set reasonable vulnerability SLAs and severities. The second thing, maybe it's like a little bit more interesting, is that we use a developer console at DoorDash called Backstage, and we try and kind of gamify remediation. So in this developer console, people like engineers can see things about their services. They can go and look at tutorials, take actions on their services, things like that. But we also surface our findings here, like our raw findings, and we try and assign points based on how many vulnerabilities are remediated in their services versus how many open vulnerabilities they are, like you have. So this kind of gamifies remediation, and it allows, it encourages engineering to be kind of like proactive about remediation, basically. And so this is kind of like the overview of what we are trying to do at DoorDash. Like I said, some of the stuff is forward-looking. Like this part especially, like reachability analysis, we're still working on it. Our SaaS tool, SemGraph, has no way of actually currently using SBOMs to determine what dependencies the code has. But this is, I believe they will add this in the near future. If not, like it's an open source tool, and they always accept contributions for parsers, especially. So, we're hoping that this is one of those future-looking things that we're hoping to have in our infrastructure. Okay. Well, that kind of brings us to the end. I know that was pretty high level, but it was also a lot. So I don't know if we have time for questions. We might have a few minutes. But yeah, I'll open up the floor to questions, and I'll leave it on this slide. So it's an overview of what we talked about. Yep.
Using the decoupling strategy, are the developers still receiving instant feedback on the vulnerability, or is there a delay?
There is a delay, but because it's happening in the build pipeline, right? And all the other things that happen in the build pipeline take longer, like testing and the actual build and things like that. So the delay is not significant. I say it takes us about a minute to generate the SBOMs and then scan it. And so because we decoupled it and we do it in parallel to the build and the testing, the delay is not significant. So it depends on the service. For example, for Kotlin microservices, we use a Gradle plugin to generate the SBOMs. We have other monorepos that, for example, use PMPM, and for those ones we use CDXGen. So we use different tools to generate the SBOM, but we put that responsibility on engineering, basically, so that we don't have to, we support them with it, but right now we're using whatever is available in that ecosystem to generate that SBOM.
In one of the slides, you said you gamify the remediation of the vulnerabilities. So do we have an example? How do you gamify that?
I should have put a screenshot from our dev console, but basically we assign points based on how many open vulnerabilities you have. So like critical vulnerabilities. So we take away points based on how many open vulnerabilities you have. So critical vulnerabilities will take away all your points, for example, and high severity will take away 10 points. So when an engineer logs into their service in that developer console, they can see that score, and it kind of they don't like seeing the red, so it kind of incentivizes them when they have some time to go and fix it, basically. The score is assigned to the service, so to the service, yeah. Actually, the SBOM actually can have a dependency tree. Yeah, so the Cyclone DX format does have a dependencies section. Yes, it does populate it as a tree. That's correct. Yep. I think that's it. Thank you.